Welcome, ladies and gentlemen, to your MN35 notes, where we're going to talk about the properties of parallelograms. This is section 8.2 in your textbook. Along with this video, you can also use that textbook as a reference on page 515. And the first thing we're going to talk about, well, clearly, are the properties of the parallelograms. A lot of them you already know. Actually, 4 of the 6 you have talked about in previous math courses. The first is that you already know that we call a parallelogram by a bigger family name, which is called the quadrilateral family. So quadrilateral. So a parallelogram is a quadrilateral, which is just a fancy way of saying that it has 4 sides. And as you look down here at the parallelogram, you can see on your note guide that it does, in fact, have 4 sides. The other thing that we already know about parallelograms is that, kind of like how many previous classes defines it, is that opposite sides are parallel. So I'm going to write that here, opposite sides are parallel. So just to get a little bit more technical, because clearly this is a little bit higher level geometry than you've seen before, I'm going to label these vertices of this parallelogram A, B, C, and D. Oops, I'm going to say that D a little bit better here. And so if we say that opposite sides are parallel, I'm going to actually list the sides that are parallel. So we can see that AB is parallel to DC, and AD is parallel to CB. And we can use the proper notation where you have your little arrows that's showing that those two are parallel. And these two segments are parallel. Okay, so that should not be anything new, but again, the notation is a little bit more up to our par. Number 3, the next thing we talk about what you already know, is that opposite sides are congruent. Opposite. So not only are they parallel, but they are also congruent. So we can say that AB segment is congruent to DC. And likewise, we can say that AD is congruent to BC. And again, we're going to put some notation up here. So AB, I'm going to put one little hash mark. And down here, DC, we're going to put one little hash mark to convey that those two are congruent. Same thing with AD and BC. Notice I use 2 hash marks because those are congruent to each other. And lastly, let's talk about the angles. For instance, angle A and angle C are congruent along with D and B. So in previous classes, you would have said that opposite angles are congruent. And again, just to get into more of the technical writing, we have angle A is congruent to angle C, and angle B is congruent to angle D. And again, let me write that notation on, or signify that information on our parallelogram. Okay. So far, nothing here that I've said is probably is very enlightening. It's a review for sure, except for the notation, which is definitely on the newer side. But now we're going to talk about the new properties, the properties that you probably would have figured out, but the fact remains that you've never really talked about them in previous classes. And I'm going to write out the first one, number 5, which is that consecutive, and we've talked a lot about consecutive. Consecutive means one right after the other, so consecutive angles are supplementary. And there's another word that we've talked a lot about. So consecutive means one right after the other. So one angle after the other is supplementary, which means that, of course, it adds up to 180 degrees. So for instance, if I say, hey, we have angle A plus, and we have A up here, and if you go clockwise around this figure, angle A and then angle B is right after angle A, so those are consecutive. So angle A plus angle B is going to equal 180 degrees. So we can kind of keep going, so we can say angle B plus angle C, because those are consecutives, and they add up to 180 degrees because they're supplementary. And you can kind of keep going. I'm just going to say ETC. So obviously, angle C plus angle D is 180, and also D plus A is going to equal 180 degrees. So there is a new property that consecutive angles are going to add up to 180 degrees. Now this last property is, I would say, of everything is going to be the most important to remember. So I'm going to put a little star by that. I mean, you need to know it all, but this is the one that we tend to kind of go back to over and over again in this chapter. It's that diagonals bisect each other. And we'll keep it simple. That just that right there. Diagonals bisect each other. Now we know what a diagonal is. It's when you go from one vertex, like this angle A, and go directly across to the opposite vertex. And we know about diagonals because of what we talked about in section 8.1's note guide. So there's one diagonal. My other diagonal, in this case, is going to be from angle D over to angle B. Here we've got two diagonals in this parallelogram. And what this property here is saying for number 6 is diagonals bisect each other. We've talked about bisect a lot. It means break up into two equal pieces. So this point right here is the midpoint of diagonals. And why? Because it's going to break this diagonal up into two equal pieces, and it's going to break this diagonal up into two equal pieces. And that is important. So you've got your two diagonals, and they are bisecting or hitting each other at their midpoints, at both the diagonals' midpoints. And I'm going to write that down here as well, that those diagonals meet at midpoint, or not maybe meets the wrong word. Let's say crosses. Another word you could use, of course, is intersects. So that is a big one. And really that sixth property is really where example 1 is coming from down here at the end of this note guide. So let's kind of get right into that problem. It says example 1, graph the parallelogram with points 1, 4, 7, 4, 6, 0, and 0, 0. Then find the intersection point of the two diagonals. So I'm going to pause this video. You're going to graph it on your own. And then from there, try to find that intersection point because, of course, we're talking about the midpoint. I'm going to pause it right now and I'll get going or start it again after you're done graphing. Welcome back, ladies and gentlemen. So right now I have my parallelogram graphed, as well as I would hope you have yours. And notice I not only labeled my vertices with A, B, C, D, I also labeled them with the points, and you're going to see where that's really helpful here in about 2 seconds. The midpoint formula I have listed up here in case you need that as a review. And I drew in my diagonals. And what it's asking here is find the intersection point, this point, and let's call it P, of these two diagonals. So we want to find that point, which is the midpoint of either AC or the midpoint of BD. So really what we're trying to find, the midpoint of AC, or you don't have to do both, but or BD. And just to show you how it really doesn't matter which one you find, let me just extend this page here in a moment. There we go. I'm going to actually do both so you see that it really does not matter. I'm going to put AC's calculation over here. So I'm going to find my midpoint of AC over there, and I'm going to find my midpoint of BD over here. So the midpoint, and I'm going to actually put a little bit more notation here just so that we know what we're doing. Okay, so to find the midpoint of AC, we're averaging our x-coordinates and we're averaging our y-coordinates to find the middle point of the segment AC. So I'm adding my x-coordinates together, which is 1 and 6 for AC, and dividing it by 2 because we're just averaging those. Same thing with 4 plus 0 divided by 2. And we have 6 plus 1, which is equal to 7 over 2, and I'll leave it like that, or you can convert it over to 3.5. 4 plus 0 is 4, divided by 2 is going to give me 2. So my midpoint, or my P point, is equal to 7 halves and 2. And if you were to graph this, 7 halves again is 3.5. So 1, 2, 3.5, and up to 1, 2, you're going to end up right at that point P, right where we want it to be. The midpoint BD, again, you could choose this. This is actually the one I would choose because it has 0, 0 as one of the calculation points. But I'm going to average my x-coordinates, so it's 0 plus 7 divided by 2, and average my y-coordinates, which is 0 plus 4 divided by 2. And I have 7 halves and 4 over 2, which is 2. So it's just kind of a show that it does not matter which, it really is actually an informal proof to show that in fact those two diagonals do bisect. That's another way to look at that. So really we're talking here about the properties of parallelograms, 6 properties. The last 2 are definitely ones that are new and you want to make sure you put in your memory. And then really example number 1 is an application of that very last property. Thank you for tuning in.